morning, students. This is Miss Codner for March the 17th. Happy St. Patty's Day. This is going to be for the lesson for the 17th and for March 18th. So today, you need a pencil, calculator, loose leaf paper for some notes. We're going to do that a little bit later on today. I'm actually going to go over 3 problems from the homework. Usually those are the most troublesome problems that I saw when I was helping people out during Wildcat Hour. And we're actually going to play Matho. And Matho, I'll explain the rules of that later. It's very similar to bingo, but we put a little mathematical twist on that. And that is actually going to be our mini assessment for exponents. So first off, there is 3 problems that I wanted off of the homework. Problems number 6, 7, and 9. So if we look at problem number 6, I have negative 4 xy being raised to the 3rd power over 8xy squared. So first off, you need to remember this. Please excuse my dear Aunt Sally. Okay, order of operations. So first thing, inside that parenthesis, can I have, or do I need to simplify anything inside that parenthesis? But just by looking at it, it looks like everything is pretty much simplified. But that whole thing is being raised to the 3rd power. So that's telling me that my negative 4 is being raised to the 3rd power, my x is being raised to the 3rd power, and my y is being raised to the 3rd power. My denominator will stay exactly the same because nothing down there needs to be simplified at all. So since I just took care of the parenthesis, we took care of the exponent, so that's what we're going to do right now. So negative 4 raised to the 3rd power, that is not negative 12, because negative 4 raised to the 3rd power is just telling me negative 4 times negative 4 times negative 4, which will give me a negative 64. So negative 64x to the 3rd power, because I'm multiplying, and y to the 3rd power. And again, I'm just rewriting my denominator because it's coming along for the ride. So we took care of our exponents. So look in our numerator. Do we have anything that we need to multiply? No, we don't. Our denominator, do we have anything that we need to multiply in order for us to simplify? No, we don't. So we don't have to worry about multiplication. Now we have division. So again, like we said last time, that negative 64 and that positive 8 in the denominator, we're going to divide those, and that's going to give me a negative 8. But like we said last time, if we're dividing, we're subtracting the exponents. So we have x cubed divided by x. That's going to give me x squared. The reason why it's x squared, this x actually is being raised to the 1st power. So x raised to the 3 minus that 1 will give you my x squared. So I'm subtracting my exponents. So if I'm subtracting my exponents, I have y cubed divided by y squared, which will give me y. And then this is my answer, completely simplified. Okay? Take it step by step. For number 7, so this whole thing is being raised to the negative 3rd power. And like we said last time, we don't want to have negative exponents. But in this case, I think it'll be a lot easier for me to distribute that negative cube throughout everything inside the parenthesis. So meaning, I'm going to take this 4 and I'm going to raise it to the negative 3rd power. I'm going to take my a raised to the negative square and raise that to the negative cube. So first things first, 4 is being raised by a negative exponent. So that means that 4 to the 3rd power has to go down into my denominator in order for that exponent to be positive. Over top, or in the numerator, I'm actually going to put a 1. Because what this is saying This is the same as saying this. Meaning, every time you have a number and you just see the number, you can put it over 1. In order for me to get rid of that negative exponent, I'm basically doing what's called the reciprocal when I flip it. So now my 1 is in my numerator and the 4 to the positive cube is in my denominator. Looking over at the a's, I have a to the negative square raised to the negative cube. So if I do that, my exponent should multiply, which gives me a to the 6th power, because a negative times a negative gives me a positive, and 2 times 3 gives me 6. So these two fractions here, we're actually going to multiply those two together. So as a result, we can actually clean that up. So a to the 6th, since it's a positive exponent, that's going to stay in my numerator. And then what goes in my denominator is going to be that 4 to the 3rd power. But we can also simplify that, can't we? 4 to the 3rd power is the same as saying 4 times 4 times 4, which gives me a positive 64. And then my numerator, I have a to the 6th. So my ending solution is a to the 6th over 64. And you're probably asking, where did the 1 go? Well, since I'm multiplying, anything times 1 is itself. So that's why I just left that a to the 6th power right where it was. Now, the fun one, number 9. Definitely a lot of people are like, I don't know what to do. Where do I go? Where do I start? There's so much stuff, so many numbers. Anytime you get math problems like this, my suggestion, always work from the inside out. So you still keep in mind, if I may write it over here, please excuse my dear Aunt Sally. So parentheses, first things first. Is there anything inside these parentheses that needs to be simplified before I can do any work? Hopefully you answered no, because 3x squared, that's already simplified. 2x, that's a monomial, that's already simplified. Negative 2x, that's already simplified. And the 6x is already simplified. So we're done with the parentheses. So now, exponents. Are any of those monomials being raised to an exponent? Yes, they are. This 2x is being raised to the 4th power, and this negative 2x is being raised to the 2nd power. So from here, we want to work it from the inside out. So this 3x squared is going to stay right where it is. I don't need to simplify that. But that 2x raised to the 4th power, that's telling me I need to raise everything inside that parenthesis to the 4th power. So that means 2 times 2 times 2 times, that's about 2, just 4 2's. That'll give me a total of 16. Because 2 to the 4th power, that's same as saying 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8, times 2 is 16. So it's 16x raised to the 4th power. Now in the denominator, I have a negative 2x being raised to the 2nd power. So a negative 2 is the same as saying squared, is the same as saying negative 2 times negative 2. It's supposed to be a negative. So negative 2 times negative 2 will give me a positive 4, and it'll be x squared. And then I'm bringing down my 6x to complete this area. Just going to erase this a little bit just so I won't confuse everybody with x's and 2's. So all that that's in blue is actually what's inside those brackets. So now I got to bring those brackets along. And remember, all that's being squared. So now we took care of our exponents. So our next thing should be multiplication. Let's look. Do we have multiplication? Yes, we do. So I'm going to take my result over here just so I can get some more room. And we're going to look at our numerator. So I have 3x squared times 16x to the fourth. So 3 times 16, that gives me 48. And since I'm multiplying, I'm doing what with the exponents? Hopefully you said you're adding them. So that means I should have 48x to the 6th power. Now let's look at the denominator. 4 times 6 gives me 24. And now x is raised to the 3rd power. Remember, there is a 1 to be understood to be there. So now we simplified in there through the multiplication. And remember, this whole answer is being raised to the 2nd power. I know it's like, oh my gosh, there's so many steps. But this is when the patience is going to kick in. If you work it step by step, you're going to notice that, hey, this is not too bad. Because now I should be doing division. I have 48 divided by 24. That's actually going to give me 2. And now I'm still dividing, and when I'm dividing, I am subtracting my exponents, so that will give me x cubed. And then this answer is being squared. So now we're at the final lap. We need to square everything inside that bracket. Even though it's a bracket, it still acts like a parenthesis. So that means 2 raised to the 2nd power is 4. And then x raised to the 3rd power being squared is 6. Because remember, when you have an exponent, a bracket or a parenthesis, and an exponent, you're going to multiply your exponents. Crazy shorthand, I know. Okay? So every time you have an exponent that's being raised with an exponent, you multiply your exponents. Okay? And then this 4x to the 6th, that's my final solution. And it's crazy because you did all this work just to get 4x to the 6th. Yes, yes you did. Okay? So those were the 3 major ones that I wanted to make sure I go on over. And after this, after all the homework was collected, we did what was called Matho. I just saw this picture and I thought it was fun. Okay, Matho is very similar to bingo, but it just has a mathematical twist. So what I gave the students was a Matho game sheet, just like the lady has in front of her, but instead of bingo, it says Matho, M-A-T-H-O. The center block was a free space, and I gave them 24 answers. So all these answers were going to be associated with the problems that I'm going to show them. They actually had to work out the problems and figure out which answer to cross off. So they can get it straight across. They can get it in a diagonal as long as it's spelled Matho. So I couldn't have any answers that are straight up and down because I'll just have straight M or A. Okay? So it was just a different way just to assess the students to see if they understood and knew how to add and subtract exponents through multiplication or division. Okay? So all I did was, here's my blank page. So let's say, for example, I wrote one of the problems up. So let's say it was a cubed times a squared times a to the 6th. They would have to write this problem down on a piece of paper and solve it. Once they got their solution, which in this case was 11, okay, I didn't write the solution, but once they got their solution, on their Matho chart, they crossed it off, okay? So the first 5 students that actually got Matho got 3 extra credit points for their assessment. So if you ever wonder, oh, does she give extra credit? I give it once in a while, so don't get too crazy with it, okay? So that's how I assess them with this one. So after we did the assessment, didn't take too long. A lot of kids actually did a great job at it. And they still, if they didn't get math though, they still got credit. So if they did like say 10 problems, I grade everything based on those 10 problems. If one class did 14 problems and it took 5 people, I grade it based on the 14 problems that they did. If they did 11 problems, like the whole class did 11 problems, and that's when 5 people got matho, then I'm grading them based on those 11 problems. Okay, so I know it's going to look different, like one class is going to have out of 10, one class is going to have out of 12, but when it comes to percentage wise, it'll be right on the money. So after we did that, I wanted to introduce adding and subtracting polynomials. So the first thing, just to refresh your memories about the 3 types of polynomials that we faced, I asked them to visualize and just for them to tell me what type of polynomials are these 3 examples. So for the first one, we have 4x plus 7 minus 4x squared. Looking at that, it looks to me that we have 3 terms. So since we have 3 terms, this is called a trinomial. I know my handwriting is really bad. It's that time of year. Okay, so since we have 3 terms there, this is a trinomial. So for the next one, 6x cubed plus x, we have 2 terms. So that means this is a binomial. Good. So if the first one's a trinomial, the second one's a binomial, what's the third one? This time we have 1, 2, 3, 4 terms. This is called a polynomial. They're all polynomials, but this does not have a particular name because anything more than 3 terms is considered a polynomial. Okay, there's not like a quadnomial or all kinds of septinomials. We don't have any of those. So right now, if you have 3 terms, it's a trinomial, 2 terms a binomial. But if I was just looking at this negative 3x to the 4th, that would be considered a monomial. Okay? So this was a quick little visualization. I took a little extra time on it for this video, but you know. But this is one of the things that they should have in their notes. So since we finished up a little bit with the exponents and we're slowly getting into the quadratic functions, the reason why I want to do this step by step so it's not too overwhelming once they start getting into it, okay? One of the things that they need to know is to identify leading coefficients and highest degrees. So when they get a polynomial, there's going to be times they're going to need to put it in a particular order. And it's going to be based on the highest degree and the leading coefficient. So of these 3 things, these are the same 3 problems that we just saw to figure out what type of polynomials they were. But I wanted to figure out what would be a leading coefficient and what would be the highest degree. So the highest degree is just another name for your exponent. So if you think about degrees as in temperatures, if I say something is 60 degrees, we usually write it out like that, okay? We usually have that small little degree symbol. That small little degree symbol is just another way of saying an exponent. So when I'm asking for the highest degree, I'm looking for the highest exponent. So for my first example, 4x plus 7 minus 4x squared, what will be my highest degree? Hopefully you will say to the 2nd power, or 2 will be my highest degree, because that's my highest exponent for that example. So now, in order to figure out the leading coefficient, I need to look at the number that's in front of my x that has the highest degree. In this case, it's not going to be 4, it's going to be a negative 4. So the coefficient is just basically the number that's in front of the variable, okay? So the coefficient for 4x is 4. The coefficient for x squared is negative 4. And 7 is just a number because it doesn't have a variable. Okay, it's a constant. So when we're looking for the leading coefficient, it's not necessarily going to be in front of our polynomial. So for the second one, my highest degree is 3. That means my leading coefficient is 6. And lastly, let me raise this up a little bit. My leading coefficient would be negative 3 because my highest degree is 4. It's as simple as that. Okay? So when we start working on more and more with polynomials, we're going to be able to pair things up, or we're going to be able to find answers based on looking at our level of degrees and coefficients. So after we did that, kind of did a quick introduction of adding and subtracting polynomials. So today, based on the math though, we really just hit hardest on the adding the polynomials. We'll do the subtracting polynomials the next class. So I'm going to sum up for today. The key to adding and subtracting polynomials is to recognize like terms. Okay? Huge thing about like terms is basically your variables with the same degrees. And it seems really technical. But what we're basically doing is playing a matching game. So we're going to match like with like. Okay? So I have 3 examples. So the first example, 2x squared plus 3x plus 1 plus x squared minus 2x plus 2. What's different about this compared to when we were doing multiplying and dividing exponents is that I have a plus sign in between the 2 parentheses. So when I see an operation, I'm actually going to do that operation. This is telling me I need to I need to add everything that's up in front of me. But I need to find my like terms. The way you can write this, you're going to start out with your highest degree. What's my highest degree in this case? It should be that square, that x squared. So anything with an x squared, we're going to write the information down first. So I have 2x squared plus x squared. And the reason why it's plus, because it's a positive x squared. Are there any other x squares up here on this listing? No, there isn't. So we're done with the x squares. So let's say I want to go looking at the degrees starting from highest to lowest. So that means what will be the next degree? If my highest is 2, what will be the next one down? It should be 1. So are there any x's to the first powers up here? Yes, there is a plus 3x and there is a minus 2x. So those are like terms. And now what's left over? Are there anything else? Yes, there is. We have our plus 1 and we have our plus 2. Someone asked me, does it matter which order these numbers occur in? It really doesn't matter, but as long as you stay true to the signs. For example, the negative 2x or that minus 2x, if I wanted to, I could have said right after this x squared, I could have said negative 2x plus 3x. That's perfectly fine. As long as that 2 is negative, that's perfectly fine. Okay? Because the key thing is here, we're not doing anything with the exponents. We're just using those exponents, or I should say degrees, to help find our like terms. So now, we got in red. We have 2x squared plus x squared. So we're going to add those 2 together. We're only adding the coefficients. So now I get 3x squared. I know you said 3x to the 4th, but we're not multiplying. You only add exponents when you're multiplying. We're just adding these things together. What we're adding are our coefficients. The 3 came from, remember, there's understood that there's a 1 in front of that x squared. Okay? So that's it for the x squared. Now our x's. 3x minus 2x will give me a plus 1x, or x. And then to sum it up, 1 plus 2 will give me 3. This right here is my solution when I add those two polynomials together. I know you're probably saying, that's it? I'm like, yeah, that's it. You sure? I'm positive. Okay? So all we're doing is playing a matching game. We're matching the x squares with another x squared. We're matching the x's with the x's. We're matching the constants with the constants. And then we add them all together. Not all of them, but we add all the like terms together. Okay? I can't go past this stage because x squared and x are not like terms. Okay? Number 2. X cubed plus 2x squared plus 4 plus 3x squared minus x plus 5. So, we need to get our like terms. But what's my highest degree? Hopefully you said that cube is my highest degree. So, let's write that down. Are there any other cubes up there? No, they're not. So the next degree should be what? Should be x squared. Okay, because we're going to do it in descending order. So we have plus 2x squared. Any other x squares up here? Plus 3x squared. Any other ones? Nope, that's it. So the next degree down, instead of 2, it should be 1. So I see a minus x up here. Are there any other just plain x's up here? No. Okay, now I got my constants, which is a plus 4 plus 5. So now let's simplify. So I have x cubed, because there's no other cubes up here. Then I have plus 5x squared. We're not doing anything with the exponents. Stop it. Okay? So we're not doing anything with the exponents. We're just using them to help us match our like terms. Then we have our minus x. Now 4 plus 5 will give me my plus 9. Anything else I should be combining? No, ma'am. No, sir. So that, right now, will be my solution. And the reason why I'm saying right now, wait till factoring. You're like, no. Trust me, it'll be all right. You'll be okay. Just keep breathing. You'll be okay. Just take it step by step. Okay? Now, let's give you a little challenge. It's just a little one. Stop freaking out. Okay. So we're still adding because I have that addition symbol in between those two sets of parentheses. We have 4x squared plus 2x plus 2. Negative y cubed plus 6y squared plus 8. So what will be my leading coefficient? You're probably saying, well, there's x's and there's y's, so where should I start? Think about the alphabet. What comes before what in the alphabet? X comes before y. So now that x, that's going to help me figure out my leading coefficient and my highest degree. So my highest degree is not going to be that cube. That negative y cube, that's not going to be my leading coefficient because x comes before y. It's that whole order power thing, okay? So if you're A, you're number 1. If you're B, you're number 2. If you're C, you're number 3, okay? So the x's come before the y. So right now, my leading coefficient will be 4, as my highest degree will be That's squared. So 4x squared. Are there any other x squares up here? No, there isn't. So now, what's the next one in line? It should be x, right? So we have plus 2x. Is there any other x's up here? No? All right. So you would think, okay, now I have to go to the constant. No. We still got our y's because our y's would come before our constants. Our constants are always at the end. What a constant is basically a number without a variable. So the next one up should be a negative y cubed. Are there any other y cubes up here? Nope. So the next one should be my y squared. So plus 6y squared. Any other y squares? No. So then now I can put my constant, my 2 plus 8. So where are my like terms? If you do it by colors, it jumps at you. Those are my like terms. Everything else is just individual or monomials. And I'm just going to bring them on down. So I have my 4x squared. I'll have my plus 2x. I'll have my minus y cubed. And that plus 6, whoops, that's it, 6 squared. And then 2 plus 8 is 10. So is this my answer? Do I have any other like terms? No, sir. No, ma'am. So that would be my solution, just adding polynomials. I know it looks crazy. You're like, I should be doing more. No, because you can't. You can't. You can't combine an x squared with an x. You can't combine y cubed with a y squared. The only time you can combine them is when you're multiplying or dividing. Okay? So next time we're going to do the subtraction. Okay? So I'll come back on and I'll show you how to do the subtraction. But for homework tonight, they do have that pink sheet. Let's see if I can show that up here. Okay. So they're completing the pink paper, but they're not doing all 5 problems. The pink paper is the homework adding and subtracting polynomials. It is on the website. I know you're probably like, about time, but finally I can get something that's on the website. But the homework is on the website. Obviously, it's not on pink paper, but you can print it up. It is entitled Homework Adding and Subtracting Polynomials, or it will be under the homework section for March 17th and 18th dates. Okay? And everyone's only doing problems 1, 2, and 3 because those are the only ones that we did addition to. So next class, we're going to do subtraction. Okay? We might start up a little bit with multiplication, but I think I might just take it as a day of reiterating addition, making sure that they understand the subtraction for the next class, and then we'll bump into multiplying polynomials on Wednesday the 23rd. Okay, that'll be the next class that we'll start doing. We're going to push everything a day. And I know I've been flipping back and forth with the calendar, but I just really want to make sure that you guys understand what you're doing. So again, you can go to the Khan Academy to look up some information. You can come during Wildcat Hour. I will actually be in the room Tuesday, Wednesday, and Thursdays. Ms. Cabanel will be here on Monday, Tuesday, Wednesday, and Fridays, okay? So if you need both of us, we can be here on Tuesday and Wednesday. If you just want one of us, come either Monday, Thursday, or Friday. All right? So, happy hunting.